We can see it there, Ronan.
Right. Can I just say one thing before I start even? If you go into the chat section, there's a file there on my Google Drive. There's some videos in the talk, but the videos don't work when they're on the file. It's an IMAX DVD from 1981 called Hail Columbia, and it's very, very good. So all the videos are on that, or in the talk are on that. It's not 40 minutes long, but absolutely brilliant to watch. So this. Okay.
Perfect. I could even have a look here, Ronan, so I couldn't see. Can I download it? And if you want, I can show it afterwards then.
Yeah. Well, they can just download themselves. The right click, they'll download it.
Yeah. Yeah. Perfect. I'll let you fire away, so.
Right. I'm ready to start, sure.
Yeah, go ahead there.
Will I start yet? Can you see the screen, by the way?
Yeah, perfect.
Can you see the screen? Right, okay, right, I'll just start, okay. So, okay, it's content of the talk. So before I say it, no, there's a top line up here, it's all blocked off. Okay, can you see the screen? Okay, right. So the content of the talk, an introduction, and I mentioned SGS 107, which if anybody asks about Columbia, they'll always ask about the disaster. I'm going to the genesis, the precursor shuttle, the development, the preparation for the first launch, Hail Columbia, some of the milestones, and the tragedy, which I wasn't going to mention at all, but I said, I know people would probably ask about the tragedy, and I said I would include it, and also some resources to bring in. So as you haven't introduced me, which is kind of strange, I said I better introduce myself. So I'm from Clonmara's, County Mayo. I started my interest in astronomy at the age of 8. My father, who you've seen a while ago, was my main influencer. Yes, he was. That was the first book he bought me, which you can see at the very top there, so you can. And then he had all these books then about aviation, rockets, the Apollo rockets, all them. So that was, of course, I was found that very interesting. Now, I was a member of Galway Astronomy Club for 18 years. Can you hear me there, by the way? Sorry.
Yeah, perfect.
Can you hear me? Am I breaking up? My screen is frozen. Yeah, my screen's kind of freezing here. I don't know whether people are seeing me or not.
No, I can hear you fine, Ronan. Yeah.
So I was a member of Galway Astronomy Club for 18 years, and I'm looking forward to going back to our meetings when they start again. At the moment, I'm recently joined the British Astronomical Association, so I remember that. My hobbies, I suppose, are binocular astronomy, astrophotography. I get the odd good photograph, you can see there on the right hand side there. Planetary science, spaceflight. I suppose what the thing that I most remember the most will be the huge aurora on the 8th of November 1991. Comet Hyakutake at Zenith in March 1996, and of course in April 1981 the launch and landing of the space shuttle. Here myself and my father, which you see everything in the photograph. So really, when you talk about spaceflight, I found this online. I thought it was a nice little bit about this shuttle. And on the right hand side, you've got a photograph of Robert Goddard. You got the launch of the the V2 rocket, and then you got von Braun. Can't think of his first name again, who invented the Saturn V rocket. So like this is a matter of chance. It's a matter of choice. It's not a thing to be waited. It's a thing to be achieved. Like spaceflight had a conception, a birth, and a coming of age, and spaceflight came to age with the birth of Columbia, which was a spaceship. Most of this talk is self-explanatory. There's text all the way through the screens. So Columbia at glance. So its first flight was in the 12th of April 1981. After the last flight in February 2003, 28 missions, 300 days in space in total. It was named after this historic poetic poem. You can see is a female symbol for the United States, part of an explorer ship, which made the first American circumnavigation of the globe, and also the name of the command module for the Apollo 11 and the first manned lunar lander. So this, of course, will come up, and on I can't see the screen there. It's black and white there. I see the actual dates. January. You find there that bar at the very top. So what is on top there? January something. January. Can't see it. Oh yeah. Okay, we got it now. Yeah. So the 16th of January 2003. I'm working here again. Okay. This small briefcase piece of foam broke off the top of the external tank and hit the leading edge of the wing at 530 miles an hour, creating a small hole. Now, the NASA engineers requested imaging from the Department of Defense with their spy satellites, but of course, the NASA management team said, no, we don't want it, and they turned down the request. And we mentioned at the end a bit more about the actual disaster. But of course, then, I mean, the astronauts themselves were told what had happened, but they were told not to worry about it. Again, what happened was complete structural breakup during re-entry at Mach 12. You know, the crew, within 40 seconds, they had their vitals weren't down, so they couldn't breathe and they suffocated. They also died of lethal trauma. I mean, their bodies were sucked out of the actual shuttle into space. Strange thing that was said afterwards, and this was happened at the time by one of the mission directors. And when you read this, it's kind of shocking the way the team at the management team at NASA thought. You know, so he said, you know, there's nothing we can do about the damage to the thermal protection system. It has been damaged. If it's damaged, probably better not to know. I think the crew would rather not know. Don't you think it would be better for them to have a happy, successful flight and die unexpected during entry than to stay in orbit knowing that there was nothing we could do until the air ran out? I think to hear that, it's just unbelievable to hear that from someone at NASA that really didn't really care about the actual astronaut up there. I'll mention more about it later on the talk. But the genesis of the shuttle program, where did this come from? There was lots of ideas. So in 1969, you had this special NASA task group set up. And Apollo at the end, and they knew, like, of course, it was all money, Apollo was. It was a race to the moon. They'd beaten the Russians, they'd gotten there. So what are they going to do next? So, of course, NASA thought that the money was going to keep coming. You know, they thought, like, because they spent about $30 billion at the time on the actual Apollo program. So their plans were huge like this. Okay, let's build a 50-person space station. You know, but we have to get something to get up there to shuttle our bus. So they were going to build a shuttle as well. Establish a lunar base was another plan. Launch the manned mission to Mars, they said, by 1985. So the annual commitment was $4 billion. That's what they needed. You know, but $27 billion in today's money. This was their plan to buy the task group. But of course, the guys, of course, at Capitol Hill weren't very happy about it, and the whole thing was cancelled straight away. You know, there was no way they were getting this money again. So they had to change plans. So this was the idea. It was an idea of a shuttle. Can you see this happening here? Hopefully you can see this animation. Well, you can see a space plane. Now this space plane is way bigger, as you can see, compared to a capsule. It's huge. And tenders went out to these different companies, to Grumman, to Rockwell, to McDonnell Douglas, and you can see they all had their different designs that they submitted. So the total cost of the development was going to be $12.8 billion. But of course, you know, unlike Apollo, which was like a blank check, they were going to have to pay for it. So they said that, okay, NASA made this commitment that they would fly 736 flights between 1978 and 1990. So 56 flights per year. That's like one a week. Of course, they thought this was possible at the time. I mean, if you look at SpaceX nowadays with Elon Musk, they're landing or launching and landing. I won't say exactly the same, but possibly it could be the same. They launched a rocket yesterday, and it landed back the same rocket for the 10th time. So it's totally usable. But this was NASA was saying that they do with 56 flights per year. The shuttle itself was built with the Air Force in mind. I think the Air Force wanted their own space shuttle, or their own, as she later on, their own space station. So they wanted something to launch by satellite, you know, covert payloads into orbit. So for that, they needed a big payload area. So the prime contractor who won it in the end was Rockwell North American Aviation. So he's going there. So there was the plan. So it was going to be there's low cost aviation. This was the plan. You had liquid hot. I just move this for a second. You had it just shows the length of the orbiter, 110 feet, expand the orbiter. So basically, it was LO2, which was liquid oxygen and liquid hydrogen. And okay, you all know what happens there, how it eventually ends up. So, let's move on to this one. So Nixon, who was not a fan of NASA, I think Nixon was more interested in Vietnam War. He wasn't a fan of NASA, but in the end, of course, being the president, he had to be there to sign it off. So on the 5th of January 1972, he signed it off. He said, "I've decided to say that the United States should proceed at once with the development of an entirely new type of low-cost transportation system designed to transform the space frontier of 1970s into familiar, easy accessible for human endeavors in the 80s and 90s." And this was the first photograph, him and NASA Minister at the time, which was James C. Fletcher. And another nice quote come up here from Arthur C. Clarke: "The shuttle in spaceflight what Lindbergh was to commercial aviation." So of course, all these ideas started coming out then of the shuttle and space station, which of course never came to fruition, but these were some of the ideas at the time in the 70s. But the precursors to this, you can see some of the fantastic planes and jets of the time, and I found this fascinating. I love jets, so I find it fascinating, even researching about it. The main photograph there, you see the X-20. The bottom left, you see the X-15. The bottom right, you have the FN-104 Starfighter, also used by NASA or by the US Air Force. The train, it's an aeronautical trainer, also called the poor man's X-15. So I'll go a bit further here. So the Bell X-1, back in 1947, you know, 157 test flights. Chuck Yeager broke the sound barrier on the 14th of October 1947. He reached Mach 1.06. There's a photograph of Yeager. He named it after his wife, fair play to him. So then you had the X2, so the next one after that. This was, again, it's just testing the envelope. Again, these planes were launched from an aircraft. They were strapped to the belly and dropped down. They didn't take off from the ground. They landed themselves. So the X2 went to Mach 316, 3,000 kilometers an hour, 20 test flights, but it was only a 4-year span. Then came the big one, the X-15, which is a most amazing plane. As again, you can see they're dropped from the belly of a B-52. They had 199 flights. The rate of climb with this rocket, this was a rocket line, same range as what was in the shuttle, at 18 kilometers per second, per minute. Now, this craft went to an altitude of 107 kilometers. So they're in space. You see down there at the very bottom, you can see the line to start. Well, I wouldn't like to call it outer space, but once you go above 62 miles, you're actually in space. This sets all types of records for speed and height. As I said, went up to 170. These 3 astronauts actually who flew it. In the end, officially became astronauts because they were in space. Mach 6.72. What they learned, what NASA learned, which was the main thing, was the data on this hypersonic flow. You know, you're in space. How do you control a spacecraft in space? So they had on the front of them, they had thrusters, small little thrusters here in the very front. If you can see my arrow, which would control the front of the plane up and down while at these high altitudes, up over 30 miles or 107 kilometers. And NASA, of course, learned an awful lot about this. And heating, now they wouldn't be going as fast as a shuttle. They'd be coming down to maybe Mach 3 or Mach 4. I mean, they would melt otherwise if they were going much faster, but of course they didn't. But, you know, they learned an awful lot about high-speed travel and that environment above 100 kilometers. Also then, of course, the US Air Force, as I said, mentioned the FN-104 Starfighter, the poor man's X-15. They had rocket on the back of it, and there's a very famous clip at the back. As if you ever watched the end of the original Right Stuff movie in 1983, to the scene of it with Chuck Yeager. That's Chuck Yeager there at the controls of this SFN 104. He brought it up to 104,000 feet. Again, had the thrusters at the front control. They learned an awful lot again about high speed wind flow. Here, this one here, he actually only had it was like a month in Edwards airspace and he crashed. He got control at 101,000 feet and went into a flat spin and crashed on the floor, the desert floor behind him or below him. So these are all the craft that we use at NASA to learn an awful information about flying an airplane into space and landing it again, unlike a capsule, which is completely different. There's a lovely photograph of the actual X-15 under the wing of a B-52 bomber and a small chase plane underneath. Another plane at times, these lifting bodies, most unusual, the flying bathtub, we call them, because that looked like, the rocket powered, not as fast, but of course, it was modeling they wanted. They learned an awful again about high speed approaches, the very steep descent that the shuttle would make as it came into land, which it did. A very unusual looking plane. I mean, it had no wings as such, but it could fly. That's the most unusual thing about it. It could fly. This was another idea stemmed from the United States Air Force. And down the very bottom, you look at this, you'll see 6 astronauts were ready for this. This was the X-20 Dinosaur dynamic soaring. Now, again, this is a delta wing, which, unlike the X-15 beforehand or the F-104, the delta wing, again, it didn't actually fly. There was an awkward search done on it, but the delta wing from the special came from this. So this was I suppose, again, as it didn't fly, but there was another research on it using wind tunnels. So this would be launched on a rocket into space. The 6th astronaut at the very back is actually Neil Armstrong, if you can't see him there, the very back of it. Again, it was like a spy plane, basically, a range of 25,000 miles. It would boost into orbit, and it would come down, like any plane, it would generate lift and go back up again and back down. So at a range of 25,000 miles, perhaps supposed to spy on Russia, the data collection, weapons, reconnaissance equipment. Never happened, it was cancelled, but of course it was replaced then, of course, by the SR-72 Black. It wouldn't go as far or as fast, but high enough to avoid any missiles. And in 1964. But anyway, would have been another amazing craft. So I can't see this now again, sorry, I can't see the screen. The development of the shuttle. There we have Enterprise, the first shuttle. So the shuttle Enterprise and the name Enterprise wasn't supposed to be Enterprise at the start. There was a petition by the guys from Star Trek to call it Enterprise, and eventually NASA said, okay, we'll call it Enterprise, and they did. So it was rolled out on 17 September 1976. It was an atmospheric vehicle only. And I don't know, can you see this little clip here? Hopefully you can, of the shuttle actually leaving. So there went 5 of these approaches in 1977. And as a young fella myself, like watching these, I was a young fella, but I mean, I was amazed. Every young lad at the time who was into space was amazed by this shuttle, and we were thrilled by it. And watching it going through the test flights, and as it went on up to launch. But it was the shuttle, you had the flying bathtub before. This was a flying brick. This thing was heavy, and even when you approach landing, it was a very steep landing approach. But what can you see this? Look at the landing. I mean, look at those people, how close they're. Shawnee, there's a bar here. I can't get rid of it. Can anybody's just remind me of it? Yeah. Can't go to the spare. Okay, let's try and keep going. So Enterprise, other than testing as an atmospheric vehicle, it was tested in launch configuration. So it was in June 1978, it was mated to the external tank and the SRBs. Different tests, launch vibration tests, tension tests in launch configuration at Kennedy Space Center. Now, also, I remember this actually when they arrived at Stansted in 1983. It was amazing. Of course, 2 months prior, they had done a launch configuration test. So it was in June 1978, it was mated to the external tank and the SRBs. Different tests, launch vibration tests, tension tests in launch configuration at Kennedy Space Center. Now, also, I remember this actually when they arrived at Stansted in 1983. It was amazing. Of course, was fantastic as a young fellow myself watching this. Never got to go over and see it, but of course everyone was wowed by it. It was also sent over to Vandenberg Air Force Base for testing also. This was, I remember at the time hearing about this, this was the United States Air Force, basically their idea, of course, was to launch their own shuttle for Department of Defense payloads. And this was to be flown from Vandenberg. You can see there from the photographs. Why there? Because there's your normal flights that would take off from Kennedy Space Center into an equatorial orbit. The best thing about flying here is you could fly into a polar orbit. Remember, Vandenberg is on the east coast of America, and you're flying. Basically, they want you to fly over water when taking off, so they could go straight up. Other than being on the opposite side, go up the east coast of America. This way, they go up over the sea, out over the Pacific Ocean. But never happened, of course, after the challenges that it was all cancelled. So this, NASA, of course, were preparing for the liftoff, and decided in 1978 they had pilots. So they had 6 women, 3 male, 3 Americans, and I can't see, of course, on the bottom. That's down again. Sorry, I just can't see my screen down here. It's 1 line. Yeah, 1 male, Asian American. So that was the 45 astronauts, right? And a lot of them did fly on the space shuttle. I don't know exactly how many, but I just know a good few with them. Of course, it wasn't just at the Johnson Space Center in Houston or Kennedy Space Center. There was a huge amount of different systems and centers. So you had the rocket motor, the main engines, landing sites, external engine where they were made. They were in this place called Midtown. The test centers, integration, the headquarters. There was so much going on. White Sands test facility. There was so many different things all had to come together. And the same thing's actually happening at the moment with the new rocket that they're going to launch, hopefully by the end of this year or next year, new SLS. And it's the same thing's happening. There's all the different centers all coming together. So there. So the Space Columbia was started in 1975. OV-102 it was called. Delivered to Cape Kennedy in March 1979. It was 3,000 kilogram heavier than subsequent orbiters. That's, I suppose, one of the reasons it never got to the International Space Station. Originally had ejector site seats. Also had this orbiter experimental support system. This was a black box, basically. NASA, I must say, happy, but they were, in some ways, it was great that they did have this box. It was there right up to the disaster, and an awful lot of information was gleaned from these black boxes that were found in Texas, fully intact. They learned an awful lot about what happened after the telemetry from the orbiter was lost. But it was an amazing craft, of course. 2.5 million parts, 230 miles of wire, 1,700 valves. Unbelievable. So that's had a 700 critical one components, which means any one of those 700 parts, for one of them to fail, would mean the loss of the orbiter. And again, remember, this is a plane. This is the most complicated piece of machinery that ever flew, compared to a capsule. So that's, it was unbelievably sensitive. It also had hundreds of sensors in the wings all over the whole craft. So the actual compartment, so you use your forward fuselage, your aft. You see all the different sections of the actual, and it was put together like that in sections, and it also came apart in sections when the disasters happened. Both Challenger and Columbia, they all broke into the individual sections. Your flight deck, your mid deck, your equipment bay. Here's a photograph, a footway of the actual side of the ship. You can see the flight deck with 4 people, and down the mid deck you have 3. There's 3 people down at the mid deck. There's the flight deck, the 4 in the flight deck. Now you can see a little hole there in the corner. That's actually with a ladder which will bring you down into the mid deck. In the mid deck, you had your sleeping compartment. You had more actually could go along here. This was your cooking area. You might think McDonald's food is bad, but I mean, can you imagine sitting in space in the International Space Station for a couple of months, eating like dried food. You know, you'd love McDonald's after it. This was the airlock, which would bring it out into the door. This was the toilet, which I'll just show. That's the toilet. You're always going to ask. I think you probably would sit here, hold on tight, and you'd be very sucked into it. This thing here was for the men, obviously. Any more about that? But I just put it funny side. The payload bay doors. In the payload were these hangers, and these were used for electricity. And remember, there was no solar cells, there was no solar panels on the shuttle, so you had to power the shuttle in some shape or form. So you would use that's what was used. These were the fuel cells. This was powered the shuttle, and for any one of these to fail, you would have to cancel the mission and go back to Earth. And it did actually happen. At the front, you had your reaction control systems, which was your front, which were kind of maneuvering in space, very similar to what they had on the X-15 and the FM-104 beforehand. And you also had another set at the back. The large rockets here at the back were called the OMEX pods, the orbital maneuvering. These would be fired when the shuttle actually took off. The main engine cutout would happen at 70 miles, and the external tank would fall away. These would be turned on. Then these would bring the spacecraft 20 miles up whatever altitude was going to, which is normally 150 miles. So that was their job, the OMEX pods. Oh, the SRBs were first tested in 1975 at the Stennis Space Center. They were built by Martin Tycol. They provide 83% of liftoff thrust. They're 3 million kilograms of thrust. And once they were in, bang, it was off the pad. As you can see there in that video. You can see how it swings back and forth. That was called the twang. Within 2 milliseconds of those engines lighting up, they were at 100%. So you can see, like, it is gone. And that's what they're made to do. I suppose one thing I found very strange when I was first learning about it, that it was powder. It's ammonium perchlorate powder. This is what it was used. It was highly flammable, of course, but perfect for launching rockets. Now again, you can see here, you can see the sea level thrust at takeoff. It went up to full thrust, and then it would actually go down and dip down here around 15 seconds for what the time was called. You hear max Q, which is the most amount of stress on the actual spacecraft, and it went through the sound barrier. It would go back up again, up to about 67%, and then fall off eventually until it would fall away, which was at SRB separation at about 200,000 feet, which is about 40 miles. For what, 52 kilometers. They're not very good at changing things from miles to kilometers. But this is what I love about you. You can see the little boosters pushing it away, and you'll see the black mark on the actual tank. As I said, this thing would continue to burn up to 70 miles when your main engine cut off and the external tank would fall away. What can I have to say about that now? I said the flame was 200 meters. Okay, so the external tank itself, this is the first rollout in 1977. It was white. The first tank were white. Then they changed it to orange because we're lighter. You had a liquid oxygen section, which has 1.7 liters of liquid hydrogen, which was the main lower tank. The top tank had liquid oxygen, and it was 636,000 liters. And this was the temperature, both extremely cold. To keep them that cold, they were covered with this spray-on foam. That is an insulation that kept the liquid at a cryogenic temperature. This foam caused a lot of problems later in the mission. With Columbia, I mean, this happened a lot. The foam would fall off at the start of the mission. The skin of the tank was only 6 millimeters thick, which was, I mean, when I read this yesterday, I was actually unbelievable. And I think this was one of the reasons why, when Challenger exploded, you can see here in 1986, O-rings failed on the actual tank. This was a blowout or a blowback. A blowout where the actual SRBs failed. As you can see, the leak there, and the actual leak went onto the external tank, and chain reaction happened, and the whole thing exploded in the space of a couple of seconds. You can see there the leak and the boom. Yeah, that's what happened. So the main engine themselves, there were these Aerojet Rocketdyne RS-25 engines. Again, 1975. There were 9 tests were done. Tested again at Space Center. 37 million brake horsepower. 13% of the actual horsepower needed to power the rocket, power the shuttle. They weren't tested together until 1981. 6.6 seconds before launch, they would come on, as you can see there, reach 100% throttle, and they'll throttle up to 104%, immediately upon lift off, and then to be reduced to 65%, again for this max fuel. You can see there on the actual diagram, you can see how the power goes straight up to 105, down for max fuel and back up again, just like the engines, or the main engines. Right. Before I get into the issue stuff, so of course NASA had to have some sort of, of course they had safety modes and that all these things could happen, but they couldn't think of the really things that did happen. They kind of other things. So they said, okay, what are we going to do if things happen when we take off, or we have a failure of one engine or 2 engines? So there's a few different ideas. Of course, was the RTS return to launch site. So there's launch, and then there was the transoceanic abort, the TAL, different places. Shannon Airport was also. You can see there the different inclinations. The other one actually, abort once around, it actually never happened. But the abort orbit only happened once in 1985. And you can see there on, this is only the equipment bay, you can see all different buttons for the different settings for whichever you wanted to go for. But it actually never ever happened. So I mentioned already my 56 flights. They had a very sort the manifest was a bit like, I can't get the word now, sorry, but ambitious, I should say, yes, a very ambitious timeline. 4 missions in 1979, 7 in 1980, and 7 in 1981. And that's the timeline there for 1981. March, April, May, June, July, August, 2 in July. Very ambitious timetable. One of those missions in 1979 was hopefully to boost the International Space Station, or the Skylab, up into orbit. That was launched in 1974. It actually came back to Earth in 1979, but the space shuttle didn't get there in time to boost it back up again. So launch preparation for the STS-1. Right. So November 26th, remember, Mission Array was brought to Kennedy Space Center in 1979. It was mated with the external tank. As you can see there, the crane was lifted down onto it. Then on the 29th of December, it was, sorry, the big bar here, and I can't get rid of it. I can't see the move. No, fine. No, okay, got it. Good. Okay. So December 29, 1998, with the rollout of the vehicle stack, the VAB, to a seaside launch at launch pad 39A. So, as you can see, been rolled out. Now, I hope this works. The engines had not been tested, I said, together. So, in 1981, February 20, they were tested together. I hope you can hear this. Difficult here. Can anybody actually hear me? Can I just ask, did somebody unmute themselves? I don't know whether you can hear that or not.
Ronan, what you need to do, I think, is under your options is to share sound when you go to play.
Can you hear me there?
Like
Can you see that video, by the way?
What you need to do, I think, is under your options is to share sound when you go to play a video like that.
Yeah. Oh. Okay. Where's that now exactly?
Float your mouse cursor towards the top. Float your mouse cursor towards the top. You see view options or something similar?
Yeah, stop video. You unmute, mute? No. Where am I looking now? Share sound. Okay. Yeah, it's the share sounds. Yeah, yeah.
That should do it. Try it now.
Was the video working by the
Video was working. We just had no sound.
Is that working?
Yeah, we have sound now.
Sorry. Yeah, we have sound now. Yeah, it's actually your voice, your subtext is coming up as your. I think it's affecting my screen.
I see that it's trying to do subtitles. I think that's another option you've activated on your end.
Okay.
I see that it's trying to do subtitles. I think that's another option you've activated.
I think I have, yes. Yeah. You stop talking. Well, that was the very first test, the very first crucial test. So basically they're ready then for so. Oh, great. So the first fatalities was an awful thing to happen. On 19th of March 19, there was technicians. They're inside this compartment, this aft compartment of the actual shuttle during countdown demolition tests. They were using this gaseous nitrogen to purge the compartment of hydrogen gas, and it was pure oxygen. Didn't actually know that the compartment was pure oxygen, and 3 of them walked into it, and one of them actually collapsed and died within a few minutes. The fellow died a few days later, and the third fellow, he went into a coma and died. He was in a coma for 12 years and died. So the first fatalities of the shuttle program, and was a memorial actually in the Kennedy Space Center. It's either in the line of duty and the names of the 3 died. So the crew was a 2-man crew for STS-1. There was John Young, Robert Crippen. John Young had flown twice on Gemini, walked on STS-2, and was commander of Apollo 16. The pilot, Crippen, he was APCOM for the Skylabs 2, 3, and 4, and for the Skylab project 1975. Now, of course, the 2 guys went through an awful lot of training, a huge amount of training. Like you had a shuttle, you had so many, with like pages and pages and pages of manuals about the shuttle, and that went wrong. So they had a huge amount to do. So, Columbia, the launch of Columbia. So, it lifted off. I actually, on the 10th of April, before it lifted off, our family, it was supposed to take off at 1 p.m. Irish time. We had dinner, like a Christmas dinner, waiting for it to take off, and the whole family were watching it. But it didn't take off. It was actually cancelled because the computers weren't talking to each other. So 2 days later, and it launched. It was the first launched American soil in 1975, and the objective was to demonstrate a safe launch into a safe return, and that's exactly what it did. They were in orbit for 53 hours. They got Tic Tac from President Vice Bush, George Bush at the time. Ronald Reagan was in hospital because of his gunshot injuries. It was attempted murder. What they were afraid of was the panels. They were being afraid that some of these panels were damaged and that the spacecraft might burn up. But then, what the video here to show, a pretty amazing video, it's about 2 minutes long. This was a video from the actual press area at the Space Center. Of course, every photograph there needs some. So I'll play, and hopefully you can hear it. That's pretty amazing, it really is. This was from the video Hail Columbia. So it's also in the chat. You go back and you see it. So let's play.
Today, we don't deal with giants once again. Once again, we deal with urgent pride. message from President Reagan, which began, "You go forward this morning in a daring enterprise and take the hopes and prayers of all Americans with you." T-minus 1 minute, 20 seconds and counting. We just see the purchase of the main engines as we prepare for ignition. T-minus 1 minute and counting. Liquid hydrogen tank is at flight pressure. T-minus 1 minute, mark and counting.
JC flight. Is a mile front or just range? It's just the tracking data flight, just a tracking data. But it's everything. Angles, ranging. But it's everything. Everything. Okay, right flight. Everything. Okay, right flight.
T-minus 40 seconds and counting. Station recorders are on. T-minus 35 seconds. We're just a few seconds away from switching to the redundant. Set sequencer. T-minus 20. We've gone for redundant set sequencer start. T-minus 20 seconds and counting. T-minus 15, 14, 13, T-minus 10, 9, 8, 7, 6, 5, 4, we drop from the engine.
Did you see that? Were you able to see that?
Yeah, it is. It paid fine there, so it did Ronan.
Okay. Sorry, I was going to be holding for time now. I'll get a bit long now.
You're fine.
So very quick, suppose I've gone to re-entry 70,000 miles to 0. Okay, so when they wanted to land, what they had to do, they did a 3-minute burn with the OMS pods over the Indian Ocean. They were flew over, and they're saying that this 40-degree angle, I mean, it was falling like a stone. So you have this 3,000-degree plasma shockwave around the spacecraft. It's going to slow down. Well, it was these. It was pitching up, so as it was going down, it could create lift. But they did these reversals, and these would slow the actual craft down using the atmosphere. But then after the entry, it turns from a spaceship into an aircraft. Now, the course was 7 times steeper, 20 times faster than a commercial airplane. It's speed of 400 kilometers an hour. So there was it came into that at a very, very fast rate of speed. So on the 14th of April 1981, you had 350,000 people out at Rotorua Air Force Base. I remember staying up till about 2 or 3 o'clock in the morning, and of course everyone was watching. It was actually pretty amazing, you know. So it was home after 2 days, 6 hours, 20 minutes. And I just go on to another video here, video of it, the actual landing. Of course, it was amazing. As the time watched was, you know, on BBC was absolutely amazing. So I just let it play here again.
This is Mission Control. Botswana has lost the signal now. Columbia is in the proper attitude for deorbit. After the deorbit maneuver, John Young will pitch Columbia down and bring it to entry attitude. The elapsed time of 2 days, 5 hours, 15 minutes. This is Mission Control, Houston.
Hello there. Columbia's here.
Hello, Columbia, Houston's here. How do you read?
Plan clear, and we're doing Mach 10.3 at 180 AS.
And we couldn't agree more, John. Your state vector's good. We got good data in.
Okay, I'll be over data's number.
Flight photo, I look exactly normal.
Columbia's reentry expected to produce a mild sonic boom centered a few miles west of Edwards Air Force Base.
What a way to come to California.
In flight photo, I still look perfect, right on the nominal.
That's real good over there.
Pilot said it couldn't be any better. 9,000. 280 knots.
I think that's real good.
Ah, sugar. Sorry, that's
This is Mission Control.
You'll have to take it up for hangar, Joe. We're going to dust it up first. This is the world's greatest all-electric flying machine, I'll tell you that. It was super.
This is Mission Control, Houston. The unofficial touchdown time, 2 days, 6 hours, 20 minutes, 52 seconds.
So that was this. Pretty amazing at the time, of course, it really was. Keep going here now. Just headlines, of course, touchdown, they all watched, you know, and that it was something to watch. You know, it was an event all Americans could cheer about. Attention to the show, and that you know, they made everything. It was pretty amazing. So of course they had to do it again. So of course it was return to sender. Let's do it again. November 80 went back up again. The second test flight, they tested this Canadair. The past 5 days, the first shuttle flight where the O-ring blow-by was just observed. It was supposed to be 5 day mission. It was cut short on those power fuse failed. So you only got 2 flights. So it's 37 to have the million miles. Yes, but only 37 orbits as opposed to much. President Kennedy did make it, of course, at the time. It was here he is photographed. Making a phone call. Now I have enough to do now, just a few more missions. So there was more test flights 3 and 4. STS-5 was really kind of what the shuttle was made to do, to launch satellites, and it was 2 satellites. It was the first mission with a 4-person crew. STS-9, which is another milestone mission. It was the first, the space lab. It was built by the European Space Agency. Experiments, so lots on different fields, physics, earth observation, science, biochemistry, loads of experiments. And it was the first time we the shuttle again. Here was a shuttle being made June, or was made for STS-28. Now the bottom point you'll see a photograph like the Hubble Space Telescope. Not. This was a spy satellite that points down. So you can imagine a 2.4 meter telescope that's supposed to be looking up, pointing down towards the. So the 30th, Columbia's 8th mission, 1989. I suppose after the challenges of that, it didn't fly for a good while. It was actually 3 years for a 5-day mission, and it deployed 2 of these. Or actually, one was a listening satellite. And the other was this spy satellite looking down. The fun thing was when they launched the special in 1981. Whether the issues have survived or not, the used spy satellites. The Crippen and Young could see space or the spy satellite out pointing towards the space shuttle. Again, similar. Now, not so long ago, the actual US Air Force donated these spy satellites, and it used a new near-infrared telescope called WFIRST. And that's the photograph of our Hawk. There's another 4-meter X spy satellite. Columbia itself was used mostly for research and space lab. If you all did a lot of missions there, microgravity, mostly might be science laboratory. It never near space. It went to the International Space Station. So it had its own set of missions that it was involved in. See all different launches. It had very good time span from 1981 right through. You can see how it's separated between all the missions. Some missions, I suppose, would be deployment of Chandra, the heaviest payload ever launched, the first female commander. Heaviest payload at 27 tons force. It was used to service Hubble Space Telescope at very high orbit, unfortunately. Space Fox in 5 days, and they installed this advanced camera for surveys, new solar rays, and new power units. That's some nice photographs there from it. But lastly, I'll move on to STS-107 in 2003. So, this was a mission that had been planned 3 years previously, but was a huge amount of experiments on 32 different payloads, 59 separate investigations. I mean, they worked 24 hours a day over 2 shifts. Go online if you want to actually find out, read about different experiments on board. I couldn't put them all here, but some of us the wastewater recycling system. They did a lot of research on cancer, ringworms, and certain creatures, insects. Some of them actually survived, but you're how to adapt over microgravity for running everything else and for respiration. So the all which the Columbia was a very, very successful mission. About 50% of the actual data was sent back to Earth, and of course the rest which was on board was lost. So what actually happened, I wasn't going to mention this, but I will mention because people will probably ask me after what happened, when actually the actual disintegration happens. So I start here on the 1st February. Again, interface, which they turned on the OMX pods to slow down, and into the depth atmosphere, which we probably over the Pacific Ocean, 8 hours. So then there was this 10-minute period of heating. With this hole in the wing, there was a hole on the wing, and it exceeds all previous flight experience. This left yaw. You'll see here this picture of actually just their instrument panel in front of them, and down here this would be flashing. This little R, the RCS thrusters were all trying to correct this left yaw. Eventually, the plasma went right through the wing, actually broke off. But the first planned roll reversal, cockpit all but shown higher pressure loss. left, if all the sensors failed, you can see all the little red dots. These are all sensors, and all of them started failing as all this plasma superheated. 3,000 degree plasma started through. What you had then, of course, was your master lamp. Your lost hydraulic pressure. You can, with no elevon, no brakes, nothing. Nothing was working on the plane, on the spacecraft to keep it in this watch angle. And eventually the angle went up into its spin, slow spin at first. And at this time, the crew would have known they were in big trouble. They were traveling Mach 15. So the big from this controlled flight, a stable flight, into its uncontrolled electric entry. So if our time that almost popping shed, 9 o'clock and 4 seconds, it all happened very, very fast. So that structural breakup within another 12 sections occurred at Mach 12 at 2,000 meters. 52 cameras. The crew module, they were inside it, and the crew module, you can see all the bits breaking off. It broke into its individual parts, like I mentioned before. The aft and the forward, and the mid broke apart and smashed into the actual crew module, and it started to pressurize, and depressurized in 41 seconds. They all would have died within seconds. If their gloves were on, but their visors were up, their suits weren't pressurized. One of them actually was sitting in his chair. So within that, by 57 seconds past 9 o'clock, they were dead. Basically, it entered this hostile environment of re-entry. So the Capcom continued to, you could hear it on the seat on YouTube, where they're saying UHF Capcom, or I can't remember exactly what they're saying, but you hear them saying contact, try contact the UHF, and nothing was happening for us. And there was no tracking. The residents of Texas heard this loud boom of the sonic booms, and then the NASA so-called contingency, which was eventually was the last vehicle, and that was the end. It was very, very sad. It was unbelievable that actually it happened again. That was, I couldn't believe it, not again. So lots of books, Common Check, Bring Columbia Home, Into the Black, special. These are some of the books you can buy online. So what would happen if Columbia being destroyed? Those plans for this new airlock, it was going to fly to the International Space Station, but 2 more Hubble service missions planned, and was due to launch this X-38. It was an emergency crew return vehicle for the International Space Station. And look at it, there was a lifting body. Again, the body was seen at the start of the talk. So, like, Discovery now has this pride in the Smithsonian Museum, of course, Columbia Museum. But her remains were used by these engineers to test and design future hypersonic field, efficient tribute, if ever need for a quiet or remarkable spacecraft. And that's at the end of my talk. That's the next talk I'm planning. When COVID is over, I can talk properly. It's just talking into a screen. This next talk I'm going to give, hopefully in 2022, about the ice giants. So thanks very much.
Cheers, Ronan. Thanks a million for that. So it was. The video playback and stuff like that is brilliant on it. So it was. I'd say when people log in and actually download the links.
There, they can download that by right-clicking it. Yeah, they can download it.
But any questions, lads or guys?
Any questions? No?
Yeah, Ronan, I just looking at your presentation there. I remember well the first launch of the shuttle. Columbia, watching the launch and the landing. I was in 2 different locations for each one. I remember it well. And just coming back to something you said about the color on the first launch, the main tank was white, and then subsequently they were red. And the reason for that was they painted it the first time, and they realized then that the weight of the paint, paint alone was having an effect on it. So
Yes,
for all
yes,
subsequent
very heavy.
launches, they didn't paint them, so it was just a bare tank. That's why it was red. There was another interesting thing I remember from it. When it landed,
Yes, yeah.
the two astronauts, the two crew, weren't allowed to disembark for several hours, and they were hopping mad. I remember one of them saying, you know, listen, lads, we got to get this sorted out. If we're going to fly to the stars, we can't be left on the ground waiting for hours to get out of here. And the reason for that was they were afraid of toxic fumes around the plane. They thought, like, with all there could be toxic fumes lying left around. So these guys had to go out in hazmat suits with sensors and everything and walk all around, testing the area all around it before
What's the desert?
let the guys out.
Yes,
Oh,
yes.
just two little things about it.
That's true. Yeah.
Very good. Anybody got any more questions there?
Yeah, I've one. Ronan, you had a diagram of the thrust of the solid rocket motors, and you said it went down.
Rocket booster, yes.
And then how did they do that? I thought you couldn't do that with solid rocket motors. Or was that the overall thrust of the vehicle?
I don't know how to do it. No, both of them, because when you hear, there's a video actually online where there's of Columbia launching, and you can hear them calling out the reduction thrust of both. Yeah, but you can see the diagram there. That's where that was the thrust vector. It went up and down. Actually, I think I know. There was different sections of the tank with different fuel. The fuel mix was different. That's how they did it. The one part of the SRB, the powder was a different type of mix. That's what they did. I remember reading that. That's how they did it. You're right. They couldn't actually flick a switch and make it happen.
Yeah, that's grand.
It has to be something because it was solid rocket booster, so it was something like the actual mix of the actual powder. Okay. Actually, Sean saying there that it was getting first. Was it that bad? But you can download all that video if you right click on